We now discuss the solution of a problem from the section Complex Analysis, and the problem is related to the Taylor series. This problem has appeared in the CSIR National Eligibility Test held on 16th September 2022, and this question is from the section B. The given question is, let f of z is equal to 1 minus z multiplied by e power z plus z square by 2, that is given to be 1 plus sigma n is equal to 1 to infinity a n z power n. Which of the following is false? Which of the following is false? We are given four options. Option 1, f prime z is equal to minus z square multiplied by e power z plus z square by 2. Option 2, a1 is equal to a2. Option 3, an belongs to the semi-open interval minus infinity to 0, closed at 0 and option 4 is sigma n is equal to 3 to infinity mod an is less than 1. We are given a function f of z as 1 minus z into e power z plus z square by 2, that is equal to 1 plus sigma n is equal to 1 to infinity a n z power n. We have to discuss the falsity of one of the following four statements. We now discuss the solution of the problem in detail, and we have the function f of z is equal to 1 minus z into e power z plus z square by 2, that is given to be equal to 1 plus sigma n is equal to 1 to infinity a n z to the power of n. This amounts to, this is the Taylor's expansion of this function f z about z is equal to 0. Anyway, now let us discuss the options one by one. Option 1, f prime z is equal to minus z square into e power z plus z square by 2. We take f of z and differentiate. So f prime z is equal to 1 minus z into e power z plus z square by 2 is the product of two functions. Apply the product rule of differentiation. So the first function into the derivative of the second, that is the differential of e power z plus z square by 2 is e power z plus z square by 2, and the derivative of the power z plus z square by 2 is 1 plus z, plus the second function e power z plus z square by 2, and the derivative of the first function 1 minus z is minus 1. The minus 1 is written here. Take e power z plus z square by 2 common, then you will get 1 minus z, 1 minus z. So 1 minus z into 1 plus z is 1 minus z square, and here is minus 1. So minus 1 plus 1 cancels, we will get minus z square into e power z plus z square by 2, and which is precisely the option 1. Therefore, option 1 is true. Let's go to the next slide, and we have the function and e power z plus z square by 2, we have written e power z multiplied by e power z square by 2. We take first of all 1 minus z into e power z, that is equal to 1 minus z into e power z, Maclaurin's expansion, sigma n is equal to 0 to infinity z to the power of n by n factorial, multiply, that is equal to 1 multiplied by that is sigma n is equal to 0 to infinity z to the power of n by n factorial minus z into z power n, sigma n is equal to 0 to infinity z power n plus 1 by n factorial. Agreed. In the first series, we take out the first term and write sigma n is equal to 1 to infinity. In the second series, put n is equal to n minus 1. Then this will become sigma n is equal to 1 to infinity z power n by n minus 1 factorial. So 1 plus sigma n is equal to 1 to infinity z power n by n factorial minus, this is rewritten, sigma n is equal to 1 to infinity z to the power of n by n minus 1 factorial. Agreed. Now take these two, and that is 1 plus sigma n is equal to 1 to infinity z power n by n factorial we have taken common, when you take z power n by n factorial common, here you will get 1 minus n. So this will be 1 minus n times z power n by n factorial. Agreed. This 1 minus n we have written as n minus 1. For that we have kept a minus here. So 1 minus sigma n is equal to 1 to infinity n minus 1 into z to the power of n by n factorial. Right. So f of z is 1 minus z into e power z square by 2. For 1 minus z into e power z, we have written this one 1 minus sigma n is equal to 1 to infinity n minus 1 into z to the power of n by n factorial. This is precisely this one. Into for e power z square by 2, we have written 1 plus sigma n is equal to 1 to infinity 1 by n factorial into z square by 2 power n, whole power n. Again, a Maclaurin's expansion we have written. Now we multiply and write it as the power series. The product we will do. So the multiplication we will do. So f of z is equal to the first one, the first series multiplied by the second series. Yes. Now f of z is equal to the first series expanded. We have expanded. So that is 1 minus 0z minus z square by 2 for 2. For 3 minus 2z cube by 3 factorial. For 4 minus 4 minus 1, 3 into z to the power of 4 by 4 factorial minus the nth term is n minus 1 into z to the power of n by n factorial minus so on and so forth. This is 1 plus n is equal to 1 z square by 2, n is equal to 2, 1 by 2 factorial into z power 4 by 2 square. For n is equal to 3, 1 by 3 factorial into z to the power of 6 by 2 cube plus so on and so forth. We have written. Now multiply and get the, what is the constant of 1 into 1, 1. What is the coefficient of z? 0z only, 1 times of 0z only. So we have written 1 minus 0z and we want to collect the coefficient of z square. 1 into z square by 2, that is 1 by 2, and from here 1 into minus z square by 2, that is 1 by 2 minus 1 by 2 into z square. Agreed. What is the coefficient of z cube? 1 into, what is the term involving z cube? 1 into minus 2 z cube by 3 factorial. That's all. That's all. From here there is no, these are all even powers of z. Agreed. Now we want z to the power of 4. Z to the power of 4. 1 into here, this one. That is the coefficient is 1 by 2 factorial into 2 square. Agreed. From here 1 into minus 3 by 4 factorial. Yes. There is another term. Here is a z square and another z square here. Multiply z square to z square, z to the power of 4 minus 2 into 2 factorial. 2 into 2 factorial. Whole into z to the power of 4. Minus, now the coefficient of z, the term involving z to the power of 5 is, put n is equal to 5 in this. So 4 into z to the power of 5 by 5 factorial. Plus, like what we have computed the coefficient of z to the power of 4 here, we will also compute z to the power of 6 here. So 1 into z to the power of 6, this one, agreed. 1 into z to the power of 6, that is 5 into z to the power of 6 by 6 factorial, 5 by 6 factorial. And a z square term here multiplied by z to the power of 4 terms here. And a z square term here multiplied by z to the power of 4 terms here. So we will get this one. We will get this multiplied by z to the power of 6 minus so on and so forth. Now, let's consider the option 2. A1 is equal to A2. A1 is equal to A2. What is A1? What is a1? The coefficient of z. The coefficient of z is 0. What is a2? The coefficient of z square. So, notice that a1 is equal to the coefficient of z is z. The coefficient of z. What is the coefficient of z? 0. And a2. What is a2? The coefficient of z square. What is the coefficient of z square? 1 by 2 minus 1 by 2. 0. Both are 0. Therefore, they are equal. The option 2 that is given is true. We have to spot that option which is not true, which is false. Let's move to the next slide. So we have that expansion here. Agreed. Now take the option 3. AN belongs to the semi-open interval minus infinity to 0 closed at 0 end. Now for A1 it is 0, A2 it is 0. That is why 0 is included. Agreed. Now A3. A3 is the coefficient of z cube. That is minus 2 by 3 factorial, negative. A5 minus A5, the coefficient of z power 5. That is minus 4 by 5 factorial, which is negative. Likewise, you can see if n is odd, then an, the coefficient of z to the power of n, is minus n minus 1 by n factorial, which is negative when n is odd. What happens to when n is even? A4, the coefficient of z to the power of 4 is this one. We have written this. Simplify, you will get minus 1 by 4, which is negative. A6, the coefficient of z to the power of 6, take this right here and simplify, you will get minus 5 by 72, which is negative. And so on and so forth. It goes on. You will see all the even indexed A's, that is A8, A10, they are all negative. So thus A1 is equal to A2 is equal to 0 and AN is negative for all n greater than or equal to 3. For all n greater than or equal to 3, odd ones they are negative, even ones they are negative. So this will imply AN will belong to minus infinity to 0, that is the semi-open interval closed at 0 and for all n is equal to 1, 2, 3, so on and so forth. 0 is included because A1 is equal to A2 is equal to 0, so 0 is included. The remaining ANs are negative. So the option 3, thus the option 3 is true. So obviously the first 3 options are true, so the false option should be the option 4. Therefore the answer is option 4. But anyway, I will show you how this is. Option 4. Sigma n is equal to 3 to infinity, mod n is less than 1. Mod n is less than 1. This should be false. How do we show? So f of z we have written here. Put z is equal to 1 in this. Then you will get f of 1 is equal to 1 minus 1 is 0 is equal to 1 plus sigma n is equal to 0 to infinity an z to the power of n. This will imply sigma an n is equal to 1 to infinity an is minus 1. That is minus 1 is equal to a1 plus a2. Sigma n is equal to 3 to infinity. But a1 is equal to a2 is equal to 0, which we have already seen. Therefore, this will imply minus 1 is equal to sigma n is equal to 3 to infinity an, where an is negative for all n greater than or equal to 3. We have seen this one. So therefore, put bn is equal to minus an for all n greater than or equal to 3. Observe that bn is equal to an is negative. Bn is equal to minus an means bn is mod an. That's what it means. Anyway, bn is minus an. Then it will be minus 1 is equal to sigma n is equal to 3 to infinity. An is bn. An is minus bn. Bn is minus an is minus bn. So minus bn. Minus minus cancels. That will be equal to sigma n is equal to 3 to infinity. Bn is equal to 1. What is bn? Bn is minus an. What is an? An is negative. When an is negative, what is minus an? It is mod. What is minus an? It is mod an. So bn is equal to minus an is equal to mod an, because an is negative for all n greater than or equal to 3. So replace bn by mod an. So that will be sigma n is equal to 3 to infinity mod an is equal to 1. But in option 4 it is given sigma n is equal to 3 to infinity mod an is less than 1. But it is exactly equal to 1. That is the truth. So the statement that is given in option 4 is false. Therefore, the option 4 is not true. So we have to spot that statement which is false. Therefore, option 4 is the false statement. So the answer to this question is option 4. That is the detailed discussion of the solution of the problem from the section complex analysis related to the Talyor series. And it is definitely an interesting problem. I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you.